organizational structure and the language of thought. So bringing Jerry Fodor, AI, and creative science together. So you're all welcome to Colin's talk. I should also mention that on Thursday, the day before, we will have a 2-hour workshop with Colin Klein. So if some of you are interested to talk to him, please come and talk to me after, and I'll put you on the mailing list if you want to read some of his work. Then it's my great pleasure to introduce as the first speaker of the year in the annual lecture series, Thomas Ryckman, who is Professor Emeritus as of this year at Stanford University in the Department of Philosophy. Thomas works in the history and philosophy of physics. He's been publishing extensively on the topics, the history of physics and how it connects with the history of mathematics and the history of 19th century and early 20th century philosophy as well. He has published several books. I will only mention 2 of them. Einstein, who was published in 2017, and an older book, The Reign of Relativity, published in 2007. He remains extremely active in the philosophy of physics, having published recently on Weil, also on cubism, and on other topics in the philosophy of physics in recent years. Thomas, the floor is yours. Thank you very much for joining us today.
Thank you, everyone. And thank you all for coming. I don't have a mic. I'll try to speak up.
We do have a mic. Can you hear the back? Or okay.
That's good. Yeah, I'll try to keep my voice up. But it's always a pleasure to be back in Pittsburgh. I was a fellow here way back in the last century. I was in Bill Clinton's first term a long time ago, and many friends here over the years. So it's great to be here and to try to tell you a little bit about Niels Bohr. And the title is a provocative one, because a lot of you will think this is a contradiction in terms, that a physicist cannot be transcendental and a transcendental cannot be a physicist. I'm going to try to convince you that there's a sense in which Bohr is a transcendental physicist. And I'm not going to go much further than that, because I'm not really going to endorse the view. I'm just trying to figure out what the view is. This worked before. It does not work now. This does not change. Oh, there. All right. Okay. This quote from Heisenberg is often read as that, according to Heisenberg, Bohr was a philosopher, not a physicist. That's not what it says. He was primarily a philosopher, but he was also a physicist. And I think that's an important distinction that I'm going to try to explain. Whoops, there we go. This is a quote that I've stolen from Chris Fuchs, who uses it a lot in a different context. E.T. James, famous objective Bayesian theorist of entropy and so forth. He talks about our present quantum formalism is a peculiar mixture describing in part laws of nature and in part incomplete human information about nature, all scrambled up together by Bohr into an omelet that no one has seen how to unscramble. We think that the unscrambling is a prerequisite for any further advance in physical theory. And there might be something to this. The scrambling is a scrambling of philosophical and physical ideas. And we're going to try to see if it can be pulled apart. Well, let's remind ourselves, this is the only slide of Kant besides the introduction slide that I'm going to have. What is transcendental philosophy? Inquiry into a priori concepts and principles constitutive of any cognition of objects of experience, blah, blah, blah. We all know this. Notice a priori concepts and principles. That's not Bohr. So there's a different sense of transcendental if you want to say it's a posteriori transcendental in Bohr, because he's going to be coming from physics and not from philosophy. But there is this view here that I call transcendental all knowledge, which is occupied not so much with objects as with our mode of knowledge of objects. And then you leave out the last clause, and that will be Bohr. Bohr has a sui generis transcendentalism, in my view. It comes from quantum theory, in particular from the discovery of Planck's quantum of energy. Not from philosophy, but according to Bohr, this fundamental discovery about nature is going to revamp the way that we think about cognition of objects, and so our conception of objectification. And it's going to have ramifications beyond physics, according to Bohr. There have been previous people who have written about Bohr's transcendentalism, and I'm indebted to them in a certain way. The book that I think is the deepest of these is a book by John Honor, who is rector or president of a Jesuit college in Australia now. Bohr's principal concerns were of a sort that which, since Kant have been described as transcendental, I do not intend, however, to make a judgment as to whether or not Bohr's thought is Kantian. And I'm not going to make that judgment either. The spirits of both men are too subtle for that. I wish rather to use the term transcendental in the broad manner in which it's employed today as signifying a fundamental concern with the necessary conditions for the possibility of experiential knowledge, and that parenthetical expression experiential is important. Knowledge of phenomena in actually the Bohrian sense. Again, Dugald Murdoch at about the same time wrote a monograph on Bohr's philosophy of physics. And he tells us that the label transcendental is in some respects apt, for Bohr was concerned with the conditions for the possibility of objective knowledge of microphysical objects. These conditions are that there should be a clear distinction between the object and the instrument used to investigate it, and that the instrument should be describable in classical terms. That's a little more fleshed out than the Honor quote, and that's where we will be going. So even in the introduction here to volume 6 and 7 of Bohr's collected works, this passage written by Jürgen Kalkar, the physicist, according to Bohr, quantum physics is an instrument to probe the foundations of knowledge. And Kalkar writes, in fact, it may not be too much of an exaggeration to describe Bohr as a born philosopher of nature, who found in physics a marvelously powerful instrument for probing into the foundations of human knowledge and man's description of the world. And I think that's the sense of philosopher in which Heisenberg said Bohr is a philosopher, primarily, not a physicist. Klaus Lanzmann tells us that both Bohr and Einstein were worried about the problem of objectification in physics, especially in quantum mechanics. Well, objectification is a transcendental problem. And in Bohr, the problem of objectification is the problem of objective description of phenomena. And that has a technical sense for Bohr, a sense that you might not know without going further into Bohr's writings. So starting from the general epistemological lesson that we learned from the quantum theory, according to Bohr, it furnishes an epistemological lesson with bearings on problems far beyond the domain of physical science. And these lessons are contained in drawing out consequences of what Bohr calls the quantum postulate. Of course, that goes back to his 1913 atom paper, where he talks about the quantum postulate as the energy change between two orbitals. But now he's using the term quantum postulate, symbolized by Planck's quantum of action, which expresses the essence of quantum theory. So this is from the famous Como lecture of 1927. Why would we want to elevate Planck's constant to a postulate? Well, it's a brute physical fact, but according to Bohr, it transforms fundamental concepts of epistemology and semantics, crucially, and even metaphysics, beginning with the concept of what is an observation, and then concepts like objectivity, knowledge, subject and object, reference, meaning, and even physical reality. And in particular, it's going to be necessary, according to Bohr, to loosen our conventions of language, which are centered around a fixed distinction between subject and object, which is presupposed by ordinary usage. It's presupposed in classical mechanics, and it's a distinction that is central to property attribution. And this is going to be in classical mechanics, the view that individual objects or systems are in definite states at all times, possessing properties with definite values, and those are properties that, if they obtain, explains the value yielded in a measurement outcome. So this is the transcendental problem Bohr encountered by focusing on subject-object distinctions, the problem of how objectivity may be retained during the growth of experience beyond the events of daily life. How objectivity may be retained, that I claim is a transcendental problem. And his proposed solution is going to relax this fixed subject-object distinction, and it's going to have wide philosophical ramifications, as he said, in epistemology and in semantics. Bohr tells us in a relatively late paper from 1958, while in the mechanical, by which he means classical conception of nature, the subject-object distinction was fixed, room is provided for a wider description through the recognition that the consequent, that's a Danish Germanism for consistent, the consistent use of our concepts requires different placing of such a separation. So let's begin at the beginning, the Como lecture from 1927. This treats something that he will call, over many papers, the problem of observation, the observational problem. On one hand, the definition of the state of a physical system as ordinarily understood claims the elimination of all external disturbances. But in that case, according to the quantum postulate, any observation will be impossible. On the other hand, if in order to make observation possible, we permit certain interactions with suitable agencies of measurement not belonging to the system, an unambiguous definition of the state of the system is no longer possible. So that's the observational problem. Now it lends itself, and Bohr has been read many times this way, as giving rise to this disturbance account of measurement, so that a system can have, a microphysical system can have a definite state that is disturbed by a measurement interaction. I believe this for many years. I no longer believe it. I think that what's going on here is something very different. It's concerning what can be unambiguously definable. So if the system is exactly definable, if its state is exactly definable, the system isn't observable, at least in the customary sense. If the system is observable in that sense, then its state lacks unambiguous definition. And so the implication here is that we have to revise the classical definition of the state of a physical system. And so we have this tension between observation, at least as usually understood, and unambiguous definition. And this means, according to Bohr in 1927, no independent reality in the ordinary physical sense can be ascribed to the phenomena or to the agencies of observation. So this presents the epistemological conceptual challenge, how to bring observation and unambiguous definition into harmony. Many people who have read Bohr stop here. I want to try to convince you that there are many more pieces of this argument that fleshes it out, that gets to what I think Bohr meant already in 1927, but becomes clearer as the decades pass. We go up to the 1950s. So the solution, which is going to be visible beginning in the 1930s, and particularly after Bohr's response to EPR in 1935, Bohr is going to revisit this differentiation between subject and object that underlies the general capacity of people to create concepts, the ability of man to create concepts. That's already in a Planck Festschrift from 1929. Objective description demands the contraposition of subject and object. This is a theme that Bohr will more and more emphasize in his writings from the late 40s and into the 1950s. The usual concept of observation, as we've seen, presupposes a sharp distinction between subject and object enshrined in conventions of language. This is an assumption inherent in ordinary conventions of language that it is possible to distinguish sharply between behavior of objects and the means of observation. This sharp subject-object distinction in everyday language and in classical physics, these are just some very trivial points about it that we're all familiar with from ordinary language usage. A subject will identify, describe, refer to an object through attribution of property concepts. This is the basis of property realism. And the paradigm of objective description of experience in everyday language. If I want to know if there's milk in the fridge, I just go to the fridge and I see that there's milk there. The referent of my term is observable, tangible. In classical physics, it gives rise to the basis of this representationalist, as I'll say. Bohr uses the term pictorial, understanding of property attribution. Objects are bearers of determinate properties independent of observation. So this gives rise to this sharp subject-object distinction gives rise to a conception of objectivity as accuracy of representation and to truth as correspondence. Now, in classical semantics, this objective description, therefore, is accuracy of representation. Representational semantics in everyday life, words refer in ordinary language usage, terms pick out and are associated with readily perceptible objects and relations. In classical physics, a representational semantics is extended from observable objects to theoretical entities, supplemented with mathematically defined, and that's important for Bohr because mathematical definition means unambiguous. With mathematically defined terms, physical states always have definite properties. Now, if you get rid of the sharp subject-object distinction, and that's Bohr's primary lesson here to philosophy, we have to reconcile two seemingly irreconcilable components. The wholeness of the quantum postulate indicates a fluidity of the subject-object distinction and the impossibility, therefore, of any sharp separation between the behavior of atomic objects and the interaction with measuring instruments, which serve to define the conditions under which the phenomena appear. That's from the famous paper on discussions with Einstein on epistemological problems in the Schultz volume from 1949. Nevertheless, there has to be a subject-object distinction. That's the basis of conceptual thought. So there must be drawn a fundamental distinction between the measuring apparatus and the objects under investigation. So when we're talking about the measuring apparatus, we're talking about what's on the subject side of this distinction. This is a Bohrian subject. In the quantum domain, it's a macroscopic apparatus because it's a subject because it provides the context for the well-defined use of elementary, Bohr sometimes also calls them classical concepts, space, time, dynamical concepts, momentum, energy, required in the objective description of phenomena. Here you see a device that is supposed to be able to measure the momentum of a particle through the interchange of momentum with the sliding barrier. And through conservation of momentum, you can find out what the momentum of the particle is. But it's not a device for measuring position. It's a very different device. For Bohr, this device, this measuring apparatus, is a replacement for the ideal of the detached observer that Einstein often presupposed, at least according to a letter of Pauli from 1955. In response to Pauli, Bohr wrote, Einstein's ideal of the detached observer may be retained in quantum physics by recognizing we are always speaking of well-defined observations obtained under specified conditions. Again, in 1958, the description of atomic phenomena has a perfectly objective character in the sense that no explicit reference is made to any individual observer, and that therefore no ambiguity is involved in the communication of information. That's what Bohr will mean by objective description. It's a subject without subjectivity. Bohr tells us all subjectivity is avoided by proper attention to circumstances required for well-defined use of elementary physical concepts. Indeed, the measuring instruments serve to define the conditions under which the phenomena appear. Once again, this passage is particularly noticeable because it explicitly ties the measuring apparatus to the subject-object distinction. In quantum physics, an account of the functioning of the measuring instruments is indispensable to the definition of phenomena, distinguishing between subject and object in such a way that in each single case secures the unambiguous application of the elementary physical concepts used in the description. So, the quantum postulate, kind of summing up here, mandates revision of this rigid distinction between subject and object, a flexible distinction or contextual distinction between subject and object requires the redefinition of the notion of phenomena. And in the quantum domain, the objective description of phenomena must refer to the observations obtained under specified circumstances, the circumstances semantic and epistemological, defined by the apparatus that includes an account of the whole experimental arrangement. So a Bohrian phenomena is an object constituted within a specific experimental context. And that is the role of a subject. This property attribution in the notion of Bohrian phenomena is therefore contextual. In quantum physics, we can no longer uphold customary ideas of properties and the behavior of objects under investigation as separate from the interaction between such objects and the measuring instruments, indispensable for the definition of the circumstances under which the phenomena occur. So contextual property attribution, this of course is going to play a role in the way that Bohr or people following Bohr will think about Bell-type experiments. Classical concepts are necessary for objective description of phenomena. The conditions of the possibility of unambiguous communication are set by experimental setups. Only with reference to a particular measuring context do the temporal and dynamical concepts, spatial, temporal, and dynamical concepts of classical physics have unambiguous meaning. So unambiguous meaning, the objective description of what we learn in experiment and measurement are set by the conditions of the measuring apparatus and the experimental setup. Bohr tells us, however far the phenomena transcend the scope of classical physical explanation, the account of all evidence must be expressed in classical terms. And this is, of course, one of the most controversial points about Bohr. Why do we have to describe a measuring apparatus in classical terms? Why can't we think about it as a multi-particle quantum state, even though we have a just so account of how that would go, like in the Bohmian theory? Well, it's because objective description requires classical terms, according to Bohr, and the classical terms are rooted in the macroscopic apparatus of the experiment. So the objective description of phenomena is a recording which is unambiguously communicable in common language without further creative treatment. It's important to emphasize this point about irreversible amplification in thinking about the necessity of classical descriptions. The very amplification from a purely quantum interaction, which is now considering measuring instruments as many particle quantum systems, to the macroscopic level of observation is important. It gives rise to this irreversibility characteristic, which is fundamental part of the very concept of what it means to be an observation. There's considerable difficulty in comprehending Bohr's response to EPR. If you limit yourself to what Bohr wrote in 1935, John Bell, rather well-known passage, says, well, imagining that I understand the position of Einstein as regards the EPR correlations, I have very little understanding of his principal opponent, Bohr. Yet most contemporary theorists have the impression that Bohr got the better of Einstein in the argument, and under the impression that they themselves share Bohr's view. Now, this was from 1981. I don't think that's true about contemporary theorists today, but I think that's largely due to the fact that Bohr's position on exactly what his response is to EPR has not been fully appreciated. In one of his responses, this was a little paper in Nature that came out before the big response in Physical Review in 1935, points towards a new definition of physical reality. And the argument at that time is obscure. Bohr tells us, I should like to point out that the EPR criterion of reality, if you can measure something with probability 1, there's an element of reality corresponding to it, contains an essential ambiguity when it's applied to problems of quantum mechanics. A closer examination reveals that the procedure of measurements has an essential influence on the conditions on which the very definition of the physical quantities in disturbance rests, since these conditions must be considered as an inherent element of any phenomena to which the term physical reality can be unambiguously applied. The conclusion of EPR does not seem to be justified. And he says a fuller development is coming of this argument. Of course, in that argument, which I'm not going to quote from, but I'll just from memory tell you that Bohr there says, of course, there's no question of a mechanical disturbance. And people have puzzled, what can that possibly mean in the EPR situation? He's talking about exactly what he says here. The very procedure of measurement has an essential influence on the conditions on which the very definition of the physical quantities in question rest. It comes out much more clearly, I think, in this little note than in Bohr's response to EPR. And this, of course, is the classical picture of reference and meaning that Bohr thought was supplanted by the quantum postulate. And you're looking at the first paragraph here under section 1 of the EPR paper. Any serious consideration of a physical theory must take into account the distinction between the objective reality, which is independent of any theory, and the physical concepts with which the theory operates. These concepts are intended to correspond with the objective reality. And by means of these concepts, we picture this reality to ourselves. So Bohr, when he's often referring to this classical account of semantics and reference and meaning, he often calls this the picturability of states and of systems. Here you see it explicit. We picture this reality to ourselves. That we have to give up with this flexibility introduced into the subject-object distinction by thinking about the consequences of the quantum postulate. So, unrestricted property attribution, as we would normally think of in classical physics, involves an essential ambiguity. It's also in that passage of EPR, since attribution necessary refers to conditions of epistemic accessibility. And under that little thing, it says semantic possibility. These are experimental conditions under which objective description can be obtained. epistemic accessibility, and semantic possibility. That means unambiguous definition. Property attribution is made only after the micro-physical system has made contact with physical reality. That's the laboratory setup and apparatus. So that's the new definition of physical reality that Bohr is introducing. The value of properties attributed to quantum objects as a result of a measurement cannot be regarded as intrinsic properties of the object itself, but only of its behavior, manifested observationally when placed in given experimental context, and a result is recorded. So property attribution is contextual, and the property concept therefore refers to the entire phenomena of which the target system is a non-separable component. The property concept indirectly represents a property of the target system. So for measuring the spatial position of a particle, we can't attribute that as a property of the particle by itself, but only of its interaction with the device that's capable of measuring spatial position. Bohr articulated his response to EPR over several decades, over and again, and added new refinements and new places of emphasis. And I think one of the most clear statements of what Bohr's position is in this old paper of Rob Clifton and Hans Halvorsen from 2004, actually responding to much criticism of Bohr's response to EPR from people like Arthur Fine and Marabella. Clifton and Halvorsen wrote that Bohr is not so much concerned with what is truly real for the, I don't know what that word is under that, the system, as he is with the question of what we could be warranted in asserting about the distance system. So what is truly real for the distance system, as he is with the question of what we could be warranted in asserting about the distance system from the standpoint of classical description. In particular, Bohr argues that in certain measurement contexts, we are warranted in attributing certain elements of reality to distant, unmeasured systems. He also claims, however, that if we attempt to make context-independent attributions of reality to these distant systems, then we will come into conflict with the experimental record. And this, of course, is the reference to the EPR state, where EPR argued that, well, if we measure position on system 1, we know what the position is on system 2 without measuring. If we measure momentum on system 1, we know what momentum is on system 2 through the conservation of momentum. It's up to the experimenter whether we measure system 1 property spatial position or system 1 property momentum. Since it's up to the experimenter, it shouldn't matter to system 2. It should have both properties. But Bohr says you can't do that because that's a context-independent attribution of reality. I find this really fetching. This is one day before Bohr died. He died on 18 November 1962, just a few days before John Kennedy was assassinated. He was here interviewed, an oral interview with Thomas Kuhn, Leon Rosenfeld, Aga Pedersen, and someone named Eric Rudiger. He says, the whole idea of EPR is absolutely nothing when one really gets into it. You may think that I say it too strongly, but it is true. There is absolutely no problem in it. Here's a familiar proponent of small metaphysics. And I think Bohr is doing his own version of small metaphysics. Because Bohr is addressing these fundamental questions that are characteristic of proponents of small metaphysics. How do successful patterns of mathematized description relate to the external world? And what degree of similitude can we expect will hold between the streams of calculation that we are able to certify as mathematically rigorous, and the behavioral expectations that we hope to attribute on this basis to the world beyond. Small metaphysics. In Bohr, this is to reconfigure word-world correlations according to the epistemic conditions of accessibility and the semantic conditions of unambiguous definition. And from a unpublished postscript to a lecture that he gave in 1957, Bohr tells us that the proper meaning of the words physical reality must refer to the content of an objective account of physical experience. So according to Bohr's small metaphysics, quantum reality, whatever that is revealed only as physical reality. That is, as filtered through classical concepts descriptive of observation and experiment. And so classical representational notions of objective description no longer obtain, even in the case of these non-disturbing measurements, such as are featured in the EPR argument. Summing up now, the fluid subject-object distinction is in fact the general epistemological lesson given by atomic physics. And of course, Bohr is going to draw many, many examples of this in other fields of human knowledge, in psychology and sociology and anthropology and so forth, in biology. Freedom of choosing the subject-object distinction, which provides room for the multifariousness of conscious phenomena and the richness of human life. Note that I have not used the term complementarity in this talk. And that's because I think it is a very narrow shoe in which to fit all of this richness of Bohr's thought. Does it provide a systematic and coherent worldview? According to Abner, a precondition to a full vindication of Bohr's philosophy is to fill the lacunae of his exposition and to transform his suggestions into a systematic and coherent worldview. Well, Abner had his own views about this, about possibilia. That's not Bohr. I don't know how he would graft it onto Bohr. Heisenberg went some distance in that direction. I'm not sure that we have a systematic and coherent worldview. I think it's been my job here simply to try to tell you what Bohr's view is. And I'm going to end with a few slides about this gentleman, John Wheeler, whom I think understood Bohr quite well. Although he uses the C term, complementarity, calling it the most revolutionary philosophical conception of our day. That's a quote from 1955 of Wheeler. Nonetheless, he saw a lot more deeply than people who just bandy about the term complementarity. Here's a famous diagram of the universe, if you like, as a self-excited circuit, giving rise to a consciousness that then can observe itself. About this, Wheeler writes as long ago as 1975, no consciousness, no communicating community to establish meaning, then no world. And I've circled that footnote around meaning because that's the next slide. But what he's talking about here is by no world, he means no physical reality according to Bohr. And physical reality is that part of reality that's invested with meaning or information. Now, about that notion of meaning that's used by John Wheeler, it's based on a statement by my old colleague, Dag van Volsdal. And Wheeler quotes it, I've found at least 7 places in papers in less than 20 years, 1975 to 1992. Meaning is the joint product of all the evidence that is available to those who communicate. The joint product of all the evidence that is available to those who communicate. Intersubjective objectivity. And Wheeler also got this right, that the role of observation plays enormously in the very definition of reality, or in Bohr's term, physical reality. Wheeler writes, the results of observations and experiments regarding what we can communicate to others, in plain language, what we have done and what we have learned, quoting Bohr, serve as the iron posts of reality. All else is papier-mâché plastered in between them. And here you see the iron posts of reality with the sheets of papier-mâché between them. Wheeler emphasized the irreversibility of the amplification of an observational result. No elementary phenomena is a phenomena until it's a registered phenomena. Why? Because a registered phenomena is an unambiguously communicable answer to a yes-no question. This gives rise to it from bit. The notion of phenomena, introduced by Bohr to meet and overcome the objections of Einstein, was something that Wheeler recognized. And this is obviously to counter the elements of reality in the EPR paper. And then, just quoting Bohr here, reserve the word phenomena solely for reference to unambiguously communicable information, in the account of which the word measurement is used in its plain meaning of standardized comparison. Thank you for your attention, and special thanks to Bob and Jeremy and Marcus.
Right, plenty of time for questions, so please raise your hand. John, why don't you start? First. Yes, you're first.
Thank you. That was absolutely terrific. As you know, I'm trying to understand Bohr is a deeply intractable problem. Can I try out something that maybe will be helpful, maybe not? I'm getting this from reading Slavoj Perovic's work. I don't think I'm representing him very well because I thought too much about it. The basic idea is to imagine that Bohr is some kind of hyper-empiricist, right? So the way that works is you don't take the starting point as Kant and German idealism, that you would take the starting point to understand what Bohr was up to as Ernst Mach, right? You remember Mach's famous slogan, the world is only given to us once,
Yeah.
right? I mean, you take that idea now, think about how Mach applied that to the bucket. It's so misunderstood, but what he says is actually very clear. He says, all we learn from Newton's bucket is that when there's a relative rotation between the bucket and the stars, then you get this concavity in the water. Then Mach goes on to tease us and says, what would happen if the walls of the bucket were made several leagues thick, right? And then he slaps it down, and then he says, this is a fiction of our imagination, and it's not our business to try and make sense of these fictions of our imagination. Right? So take that framing, and now think about what Bohr's doing. Right? Bohr is saying the world is given to us just once. Every measurement that we have involves an apparatus that has classical description, right? And we stop at that point. Ours is not to ask about fictions. What would have happened had we have done some different measurement, right? That's not the business before us. It is simply to deal with the experiments as they are given to us. And so, the fact that this particular apparatus was engaged in whatever we experience, that is constitutive of our experience and has nothing to do with some other experience. So to put it in another way, in perhaps a more recent philosopher's language, Bohr is denying counterfactuals. whereas EPR depend essentially on counterfactual.
Oh, absolutely.
Yeah, what would have happened if.
Right.
But if you think of Bohr as a hyper-empiricist
Right.
who simply doesn't like counterfactions, wants to have nothing to do with it,
Right.
then, now, I think that's only a starting point, because Bohr says more,
Mhm.
right? The influence of
Right.
the apparatus on the conditions of,
Right.
I know it's
Yeah.
non-mechanical, I don't
Yeah.
know how to make sense. But I've always found that just to be a comfortable place to start, or I've come to it as a comfortable place to start. And then I don't find such discomfort with what he's saying. I think it's wrong. I think to deny counterfactuals to science is really disastrous. But it becomes intelligible. Anyway, so that's a thought. What do you think?
Very nice. So two things pop to mind. One is, of course, in measurements, we have the statistical results of quantum mechanics to help us along. And we have things like the Bohr rule that help us with that. So we have, if you like, what's Schrodinger's word for this? A notebook or of statistical outcomes suitably packaged in quantum framework to lead us to have expectations about what the result of a measurement is going to be. So doesn't come as a complete surprise. I guess that's just a minor thing about the world only happening once. The thing that does also come to mind is in the big reply to EPR in 1935, Bohr does say things like, if we make a measurement of position on a particle here, then if we had a device for measuring position over here, we could talk about the position of the distal system. We don't have to actually make that measurement, but we could talk about it. So that's a very weak sense of counterfactual. It's kind of semantic possibility of talking about what a measurement means over here based on the setup here and the setup that we have here. If we have a measurement from an apparatus for measuring momentum here, we can't talk about measuring position, even if we have a position measurement. So there is that kind of counterfactual language in the longer reply to EPR, but it's very weak.
Yes.
I was going to ask a separate question, but I actually wanted to make a comment. I mean, there is a way to present or argument behind EPR without it's not correct. It's just the way it's initially wanted to present it before the paper was published. Simply the idea that once you make a measurement on one side of Alice makes her measurement, she immediately comes to know what the outcome was. No confidence, just she comes to know something.
Mm-hmm.
How could she have come to know this? One mistake is completely symmetric between the two outcomes. So therefore, there's more structure to the world or more things of the world than the one mistake represents, because immediately there is no possible influence. And so therefore, one mistake is incomplete because her knowledge exceeds what she can gain by making a mistake. So, I mean, yeah, so I just wanted to make that comment. In a sense, Einstein's argument is it's the EPR version, which had the sort of commuting bases.
Right.
Yeah.
Right. But if Alice is by making a measurement there is going to know immediately what the result of Bob's measurement of a certain variable is going to be, then Bob at least has to, if he were to make that measurement, her knowledge would be confirmed. Right? But he may not. Well, I think that's more a grist for Bohr's mill. I think that without the experimental setup that we have to implicitly refer to when we talk about Alice's knowledge of what Bob's going to find out were he to make a measurement, we have to know what Bob's situation is, what his experimental context is.
But we could stipulate that Bob makes a measurement, right?
We could
Yeah.
stipulate.
And then in those situations,
Yeah.
the argument would apply.
Yeah. You're right.
The possibility here.
Yeah.
You only get half the argument. The idea was that if Alice had made a different measurement,
Yeah.
then Bob would have gone with a different result.
Yeah.
Bohr wants to deny that. He's saying you're now moving to a fictional world that didn't actually happen.
I agree, but we can. Have,
But you said you had another comment.
yeah, is it okay? Or?
Yeah, no, go ahead. Yeah, absolutely.
I guess I was kind of curious about the sort of transcendental part of this. So, obviously, you're not trying to associate Bohr with Kant.
No.
But I mean, if I think about Kant, there he has a metaphysical picture in the transcendental idealism, which gives him the resources to explain why we have this kind of a priori synthetic world. And it's quite a radical metaphysical picture in which all you can really know is this world of phenomena and so on and so forth. In the Bohr case, it sounds to me that he wants to sort of have it both ways. Right? He wants to sort of be able to have knowledge of the empirical world. There's no kind of phenomenon to split or anything. But still have it be the case that there are these sort of constraints on what is even the preconditions of knowledge. I'm not articulating this very well, but I'm sort of worried that, sort of trying to have your cake and eat it too, right? So somehow, I don't know what the metaphysical picture is supposed to license this.
Well, there is two things to say about this. One is when Bohr is talking about classical concepts, he's really almost always talking about kinematical and dynamical concepts. The kinematical concepts would correspond to the transcendental analytic a priori. The dynamical to the transcendental analytic, the table of categories and judgments. So he's putting together these two aspects of transcendentalism through this rubric of elementary concepts that are used to describe our experience of quantum phenomena. And then the second thing is, what is the second thing? What did you say at the very end?
I'm just worried that what is the metaphysical picture?
Oh, right. So the metaphysical picture is un-Kantian in the sense that, well, it depends on how you read Kant, and many people have read Kant in many different ways. But one of the things that you can get out of reading Kant is that we have knowledge only of phenomena. What do the phenomena tell us about the so-called Ding an sich? Well, you don't know. There can't be any causal connection between them, for all sorts of reasons, and maybe, but Bohr is pretty explicit, although only in a few places, that what we learn through study of quantum phenomena in the measurement context does give us some handle on whatever quantum reality is, but it's always as filtered through these conditions of epistemic accessibility and semantic unambiguity. So it's giving us some filtered view of the thing independently of, as you were, observation and measurement. But observation and measurement are always going to filter what we can say about the thing in itself. So there is some kind of, and if you want to put it, realist knowledge about quantum reality independent of measurement and observation. It's only in a few places that Bohr ever alludes to this, that he does allude to. So he's not an instrumentalist, he's not an anti-realist, he's not a neo-positivist.
Hi, thank you so much. First, at the very beginning of the talk, you made this claim that I sort of lost track of later on, which is that Bohr's philosophy is a response to quantization of energy. But I didn't really see how that fit into what you said later.
Yeah, so what I tried to do at the beginning of the talk was to say that Bohr's idea from the get-go was that the quantum postulate changes the very concept of an observation. That brings in its train the change in subject-object relations and in property attribution. So there's a long avalanche of consequences from changing the concept of observation that you can, in classical physics, you can observe something without appreciably disturbing it, just as in everyday life we do that. But that's not possible because of the interchange of energy at the same, basically the same scale as the system that you're interested in, the target system. So you have a new concept of observation. And what Bohr then tries to build is how you can get this new concept of observation, knowledge of phenomena, by introducing this flexibility into the subject-object distinction, which is a contextual distinction, depending on the measurement setup that you have. So that's what I was trying to say.
I guess I've always been confused about why exactly quantization of energy takes this radical shift in classical mechanics. Because like Heisenberg's original argument in certain principles, very classical disturbance picture. So
Yeah.
you can sort of get arbitrarily good measurements, but there's always be a disturbance. So yes.
Well, isn't that pretty much along with, you no longer have the old picture of what an observation is, that there is negligible, and by negligible, Bohr means, it's not even an issue for approximation or calculation. You just and that's not the case.
I'm wondering, and this is very Whiggish and realistic, but just reassessing in hindsight Bohr's claim about this central observation being the distinction between subject and object. I mean, if I look at the last 40 years of quantum mechanics, it feels as if, however valid that was at one point, the description of how physics practice engaged with it, it's much less visible. I mean, the degree to which one studies the quantum classical transition dynamically, the degree to which one models the measurement process quantum mechanically, the way one studies things like Zeno effect, the way that the whole church of the larger total space notion. I mean, do you think that those are reasons to act against that Bohrian notion? Or do you think that's something about the modern practice of quantum mechanics and so on?
Well, I agree with you that it's lost sight of. The Hunter book that I mentioned earlier goes on and on about subject-object, but he doesn't get it quite right. He doesn't realize that Bohr's subject is the measuring apparatus. So in the early days of quantum mechanics, and that's where we have to situate Bohr if we want to read it sympathetically, we can kind of see how these thoughts were coming to him in revising subject-object distinctions and predication of properties. Now, how this would play out in quantum information theory, in I don't know, decoherence, in whatever it might be that we want to study today, that would be an interesting thing to see. Can we find that there's no longer a fixed subject-object distinction in terms of what we say about the result of an observational measure?
I mean, I think about sort of the way Simon Saunders reads Bohr as very much, which is quite synthetic in some respects,
right.
But very much along the lines of the Bohr had a kind of logically and philosophically coherent idea about how physics and indeed science might develop in light of his observations and what we have to. On the other hand, with Saunders reading, that's not turned out to be how science either quantum mechanics or and again, that can obviously be salient to the synthetic reading of Bohr in the time. Just I'm thinking of Saunders' analysis in the light of your exegesis of Bohr.
Good. Yeah, I think we also have to always remember that even after Einstein's death, Bohr always had Einstein in mind when he was making his arguments, because he was really the target of what he was trying to do. And in that passage from EPR, it's explicit there. The ordinary semantics of everyday life and classical reference and meaning and truth is just right there. That's what physical reality is. And I think that Bohr, in his counters to Einstein, was always trying to stress exactly why that picture has to change if we're going to take an accurate account, or we're going to have a satisfactory account, not necessarily accurate, but accurate as well, but satisfactory account of what we do in quantum experiment. Now, it's a fair inference to say that, well, that's not really how physics developed, but it didn't develop in Einstein's day either.
So that's
Yeah. There's this famous argument of John Bell. Because why should we think observers as primitive terms of species when, by all reason, observers under the physical system constituted by the same thing? That's kind of fighting against any kind of primitive subject-object distinction, because that seems to just be false, given the way in which we think observers are actually physical systems themselves. So I wonder what Bohr, or your reading of Bohr, stated that kind of objection.
Yeah, well, when I talk about a Bohrian subject being a rigidly bolted, measuring apparatus, I'm using it almost in a metaphorical way for the fact that it is the setting for the conditions of semantic unambiguity and epistemic accessibility. Now, John Bell's notion of observer, dog, bee, you have a PhD, blah, blah, blah. We're not talking about consciousness. Bohr, and I think that's partly what Bell was getting at, that we don't need consciousness to talk about measurement. Bohr was not talking about consciousness at all. He wants consciousness completely out of the picture. And so I think there is, in some ways, no real issue of conflict between John Bell against measurement and Bohr in his full picture of this flexible subject-object distinction.
Please go ahead.
Yeah, thinking about Kant's theory, so our cognitive faculty, right, that we are able to see things, hear things, smell things, it seems quite primitive that we were just born with this ability, right? It seems very primitive, but I was wondering for Bohr how primitive this constraint on the measurement encourages is, because it seems like we humans are designing these measurement imperative and making choices in the engineering process and getting informed by the theories and new theories we have to define those imperatives. So it doesn't seem as primitive as our cognitive faculties,
right,
as how Kant thinks. So I was wondering what do you think Bohr say?
So I think what is primitive for Bohr is the fact that we borrow these concepts of space and time and force and so forth that we know from everyday life, and we use their classical physical counterparts in describing the results of measurement outcomes and measurement setups. So the primitive is that we are critters, if you like, that use these ordinary concepts from daily life and boost them into classical physics. And they create, in some sense, the conditions of objectivity through the experimental setup in which we can have descriptions of quantum phenomena. That really has nothing to do so much with sensibility or senses, but it has to do everything with conventions of language that are borrowed by classical physics from daily life, and that Bohr sees have to be revised if we're going to properly describe quantum phenomena.
Our understanding of how to design measurement imperatives theoretically can change as science advances.
Well, yeah, but the results of measurements almost, in Bohmian theory, it's always a position measure. It's going to be a pointer on a dial or whatever it is. Spatial and temporal concepts are absolutely fundamental to how we can communicate intersubjectively, because they have unambiguous meaning in the laboratory context.
John?
Just wonder if you could, a few thoughts about something that's always puzzled me. It seems like we have two Bohrs. Right? There's the Bohr of 1913, the trilogy, Bohr atom, and then there's the later Bohr that's responding to EPR. And they just feel like they're almost two different people. Certainly, Einstein's remarks about them reflect a tremendous difference. I know you know the quotes probably better than I do. That, you know, we know what Einstein thinks of the later Bohr. I think he calls him the Talmudist. Yeah, you know, obscurantist. In other words, is what he's thinking, a legalistic obscurantist. Whereas the Bohr of the 1913 trilogy for Einstein, you know, Einstein says he was astonished by the paper, and he called it the highest example of musicality. I think was the, you know, because the two Bohrs are so close together in time, it's hard to imagine that they're different people, right? I mean, just maybe they are different. Maybe the Bohr of 1913 is doing one sort of work, and the Bohr of the later Bohr is doing a different one. But it would be lovely if we could find some kind of commonality, something deep within Bohr that is somehow driving, you know, both stories. I've tried to think if a kind of hyper-empiricism would do it. Maybe a hyper-empiricism would allow him to say, well, I'm just going to turn off all this classical physics if it doesn't conform with observation, because I'm a hyper-empiricist, I don't need to worry about it. That feels really cheap, right? Have you thought about how we
I have.
the two Bohrs together?
I have. So Bohr 1913, he takes this radical step, right, of you can no longer visualize transitions between orbits. Give it up. You know, just obeys this relation. Delta V equals C. Now, this symbolic, this introduction of a non-visualizable symbolism is really important for Bohr. And I think it grows as quantum mechanics develops, or as the old quantum theory becomes quantum mechanics. I was just recently reading a paper of Don Howard, and Don had this quote from a Bohr paper from 1923, before quantum mechanics, where he's actually talking about the unvisualizability of atomic systems and why this is going to present problems for how we describe phenomena, or not phenomena in Bohr's sense, but our experience. So I think that Bohr came to this gradually. I don't think it was suddenly like Saul on the road to Damascus. I think that he was of this persuasion that quantum mechanics was going to be as he says in later writes a lot, that it's just a symbolic algorithm for predicting results of experiments. And we shouldn't think of the state of a quantum system as described by a wave function. It's just a calculational device in which that we use in, as it were, updating what we expect from an experimental outcome. So there is no, as we know, there's no collapse in Bohr because there is no such thing as a physical wave function which propagates in whatever space it's supposed to propagate in. He has this very strongly, in some ways, it's a kind of Hertzian view of what, not axiomatic, but Hertzian in the sense that it's symbolic view of what physical science is. And so much of what he has to say about renunciation of that classical picture has to do with the fact that there are these downstream consequences of the quantum postulate that have to be taken into account.
I wanted to come back to something that came out of today with Sabrina, and that's this idea of all measurements being position measurements being positioned on dials. And this shows up in the way you're describing Bohr in very different contexts, shows up in Bell. I just want to wonder about what are we supposed to take from that and quite what work is that doing? I mean, obviously, there's some sense in which the detector system and Atlas in the Higgs experiments, or the gravity wave astronomy devices that pick up flying black holes, there's obviously some sense in which ultimately those things display, I mean, something on the screen or something. But the gap between what's being physically measured and looked at and the way that eventually translates it through to some result is dizzyingly fun. I mean, there's some sense of it. If I were to say for the LHC process, what was the physical mechanism of that apparatus giving the readout that we found at Higgs? I mean, I'm not sure I wouldn't want to say that the apparatus includes the entire search team, and the readout mechanism was the team leader opening a bottle of champagne and saying, I just not sure how to understand what the connection is when we go from these sort of relatively direct, quasi-classical processes of measuring where a particle went to the kind of thing we really see in high energy big physics.
Sure. So that's good. The way I think about it is this, and I don't know if this is, if Bohr can say more than this, but I think he could say at least this, which is that, look, remember what Wheeler said about a recording being this measurement of a phenomenon. It's not a phenomenon, it's a registered phenomenon, that kind of thing. So what does that really mean? Well, registered means that it's shareable. And it is, in other words, intersubjectively objective. Now, we're not communicating our experience of looking at that chirp, like in the collision of the black hole. We're not communicating our experience of that. We're looking at the graph, and we see the spike. And when you see that, that is what's communicated to the rest of the world. And they say, okay, that's the collision of a 29 solar mass and a 32 solar mass black hole. I think it's something like that.
Or to expect these questions. So I was just again thinking about the analogy between some elements and force, and thinking that goes into the theory of distribution, where you have a lot of latitude. So in some forms of spectral decomposition, you get a certain class of distributions. But to make sense of them, then you have a space of test functions that smooth them out. And that's like pure observation. And then each different observation device will handle the same underlying distributions differently. But so it made me, Bohr uses all these appeals to classical mechanics. But it seems like on this kind of analogy, we need more of a story about it's the equivalent of taking a description of an optical system with lenses and all that sort of thing, and somehow translating it to these mathematical representations of the space of smooth functions, the test functions of the distributions. And he goes too long. Uses that, take a classical device without giving you a clear sense of a mathematical representation. Now, a test space is a pretty clear representation of something, but it's a long way away from what Bohr actually says. Isn't there some need for improvement on that point?
Yeah, I think there's a lot of need for improvement.
So I mean, you can take I don't know what a classical description is, but I can describe a telescope or a microscope in classical optical terms. Right?
Yeah.
And it, in some sense, probably will, if intuitively smooth out certain sorts of signals, and will do it in a way that you can tie to your bodies. Right. It seems like there's a need for a transition between an intuitive sense of that's a classical description and these mathematical operations.
Mhm. Yeah, good. Obviously, Bohr uses the few illustrations of classical apparatus, these very clumsy bolted things, partly, I think, to emphasize the macroscopic character that is important for the application of kinematical and dynamical concepts in describing measurement outcomes. He has never, to my knowledge, gone any further than that. I think in some ways, these illustrations that he gives are rhetorical to emphasize their classicality, their macroscopic character, and not how they function at all, except that a device for measuring position is going to be different from a device that's going to measure momentum. And one and the same device can't do both. Now, as to actually how that measurement of position takes place, that's all left in the fog. And that's true of.
Shouldn't we expect that even devices that both aim at measuring position are actually going to give you typically different results? And something or that you have to compute. I mean,
Well,
that's the idea you get from the electricians and so forth. And they think that from.
yeah, this might go back to John's point about picking up on Mach about this hyper-empiricism. The world only happens once, so that the idea that you can make a measurement, but you can't then speak about what would a different device capable of measuring that that quantity, what would that device yield? Would it yield the same result or not? Again, it's the counterfactual language that Bohr would permit, but also he's only concerned with this flexible subject-object distinction and responding to those who think that property attribution is just as it is when you have the classical context of observation. It's not. So you've got to factor in this new quantum postulate and what that will do with any kind of measurement of any quantity. And for Bohr, that's going to be involved in this notion of phenomenon. And somehow in the description of the experimental setup, the different device for measuring this or that quantity is going to be there. And I think in principle, sympathetically, if I wanted to be really careful about it, I think in principle, that experimental setup would include different kinds of position measuring devices in the description of a measurement. Thanks.
Thank you so much for the thought. This is something that I perhaps the answer is just in that. But given how much you talked to Einstein, was there any of the same kind of issues about non-classicality, or at least the abandonment of classical type concepts that Bohr brought up in relativity? I mean, so here's an example. The loss of absolute simultaneity was for some physicists, I know the example is Lawrence, it's particularly hard to swallow the pill. It's not clear Lawrence swallowed it at all. Did Bohr at any point talk about this? Did you think, for example, that absolute simultaneity was the kind of concept that was kind of a necessary precondition for even understanding what the system was about?
Oh, no, he talked about it in several places and always positively, because what he's concerned with is how objectivity may be retained through the growth of experience. And so physical experience, goes from classical physics to relativity. And then he goes on and on about the Einstein's finding of no absolute simultaneity. And that this therefore changes the description that we have of our experience. Differently co-moving observers, right, can disagree about the order of two events. We've learned this. We learned this in physics. And this is another example of how our descriptions of experience have changed with the development of physics. He sees what he's doing with quantum mechanics as just another step of that change of semantics and descriptive apparatus, if you like. Revising concepts of how we can describe our experience. In this case, the attribution of these fundamental concepts of space-time.
Yes, sure. Why the double strategy? Why kind of the double standard? Why is quantum mechanics one where you, in special attribute, states it all in strides from quantum mechanics?
Well, because you start with the problem of observation. What's an observation in relativity theory? Well, intersection of two world lines or a point coincidence or something like this. And that is, in some sense, something that can happen and be thought about independently of any necessity to take into account the means of observation. And you can't do that in quantum mechanics. So the observational problem changes from relativity to quantum mechanics. Yeah.
So I wanted to come back to the transcendental part at the beginning, and when I think about transcendental physicist or philosopher, I think about telling us about the necessary conditions for the possibility of something or other. And then Bohr's, you sort of had two kinds of things that Bohr always emphasized the necessity of. One is starting with classicality or classical physics, and another is an apparatus or a measuring device to interact.
Mm-hmm.
And the first aspect of my question is, does it have to be classical physics per se? Or I always think about, what about aliens? Do they have to go through the exact same path that we did to get to quantum mechanics, or could aliens have, as it were, come by a different route, which would make the claims of necessary conditions for the possibility somewhat dubious? And it seems to me that talking about classical physics per se as the necessary conditions strikes me as less plausible than maybe just the idea of some sort of meso or macroscopic measuring or observation device.
Mm-hmm.
Anyway, I wanted you to comment on that.
I think Bohr might respond something along the following lines: that the quantum of energy is a universal constant. It's true for the aliens too. So they're going to, unless they're so clever that we can't understand what they can do, they're going to experience the same observational problem when they interact with a target system. And whether you think about the measuring apparatus quantum mechanically or whether you think about it classically, there's still going to be that interchange of energy. And that changes the observational situation. And then the next step is, well, what follows from that? And you get to this, well, subject-object distinction has to be given up. There's no longer a firm object and a firm subject, and the subject and predicate definite properties of the object, because the object is, when we know it, it's no longer what it was before we knew it. It's something else. It's a phenomenon. So I think Bohr would just dig in his heels there and say Planck's constant is universal.
Been going on for nearly 1 hour. So, all right. If not, let's thank our speaker for today. Invite you to reception. This year we're going to do it on the 11th floor.